that said, we'll go ahead and get started. This is the first chapter where we're going to be splitting it into two different ones because for those that have looked through it already, it's a bit of a longer one. Today, we're going to more so focus on a lot of the calculations. And then next Tuesday, which is our last in-person one before the assessment, we'll focus more. So there'll be some other calculations, but then we'll transition a bit more to the graphical side of the chapter. So get ready to have a lot of formulas and a lot of math in this lecture. Now, near the end of it, we'll actually do a little bit of a logic exercise that you will see pop up on the assessment. So for those of you that did do the Sudoku bonus exam and actually tried it, you'll see why, when we get near the end of here, why I recommended you at least go through it. Now, since this is a two-parter one, we'll do the motivating example here and then just continue the lecture on Tuesday. So it looks like most of everyone's here. We'll go ahead and get started with our motivating example. Y'all remember last time with our motivating example, we talked about grade distributions and whatnot, make things hopefully as easy as possible when you start moving on through your undergrad. This time we're going to get to a bit of a darker side of academia, especially as it pertains to last semester and the back half of the spring. And now this one, I understand as some of you are shy to answer this, so I'll make sure, this is mostly for the in-person people, so I'll put it in a way where you might not feel as shy. How many of you took a class either last semester or in the spring where you know of someone or are aware of cheating that happened in that class as a result of it being online? Those of you at home, that's pretty much the entire class. It makes sense. If you go online, they don't proctor it, they come from pools that are published by publishers, and it's done outside of Blackboard, there's no monitoring whatsoever, and they claim it's supposed to be closed note, closed book. The only thing stopping someone from just having the whole book and the whole internet right in front of them and having their phone out and messaging someone is just honor and decency. Now, I'm not saying everyone's dishonorable, but if that final test could be the difference between you passing the class or failing, it's understandable if you take that opportunity because you got to move on through your degree. So the thing is, obviously, cheating could be going on, but you actually have to figure out that it's happening. And a lot of times, some instructors, they just have generally no idea what's going on. Others know it's happening, but they just don't want to deal with it, so they don't do anything about it. Now here, right up here, move this out of the way for those of you in person. This is from a differential equations class that one of the faculty members in our department very graciously shared with me. He's a colleague I work with. And it shows the average and the median on the 3 midterm exams. I'll explain what average and median mean in a second, but the very short story, y'all know what an average is. The median, halfway point. So if we took all the grades and ordered them from lowest to highest, the median's the halfway point. You'll see the first one, the median and the average are pretty much the exact same. See the second one, that median starts to get above the average. And then the third one, they're just on their own 2 entirely different planets. And remember, this is a class size when he was teaching, it had like 100 people. To have a 15 point gap, I think y'all know, for those of you that have looked at before, that's practically unheard of. That was one sign to him that something was going on. So what he did is for the second midterm exam, he took all of the grades, the exam scores, and made a histogram of them. That's right here. Let me scroll down just slightly. That's right here. Y'all recall chapter 2, what a histogram is? We have our frequencies. And just as a little bit of a recall, if it wasn't for that thing in the 60s, 70s, then you would call this skewed left. But the thing is, we have quite the peak around the 80s, which, that makes sense. That's typically more most exams are. Most of the average person tends to score in the low 80s. That's just how the way most things are. Doesn't matter if the instructor is really nice or really mean. That's where most of the scores tend to be. Makes sense. From there, you would expect it to kind of go off to the left and the right, maybe a decent amount of A's, then a few really high A's, decent amount of C's, a few failing grades. That's typically what it looks like. That's all we have here at all. This part of it looks relatively nice. Over here, we start going down, and then we jump up before going back down. Those of you who at least were able to be here in person or got the makeup, we remember we have symmetric, bimodal, left skewed, and right skewed. Just for those of you in person, how many of you think this is symmetric? left skewed, right skewed, bimodal. Yeah, that's bimodal. And we talked about with things like this, you should never have bimodal. If everything's nice and fine, there's nothing sinister going on, it's not going to be bimodal. And so when he saw this, he's like, okay, something's going on. And so what he did was on the third exam, he was able to design it to where it was much easier for those who were being honest and nearly impossible for those who were trying to cheat. And that's what happened. He figured out there were like 20 to 25 people cheating. Lo and behold, 21 from 60 to 70. I'm not saying all of them cheated, but there's some there. Because what he figured out they were doing, they were taking the questions and just copy pasting them into Chegg. And the Chegg people would try to answer that. They copy paste that. So what he did was he designed them in such a way that one of two things happened. Either a wrong answer was already there, or the Chegg people wouldn't know how to do it. Now you might say, oh, that's a mean thing to do. Yeah, sure, I can see that argument. Counter argument, if the exam's that easy, you probably shouldn't be cheating. So you can see just by using this histogram comes from chapter 2, but also using these, what we call measures of location that I'll talk about in this lecture. Even if you have no idea cheating's going on, you can use it to figure out that it is. Now, there's a lot of other things, like let's say you're working at a business and let's say you're going through the company's finances and they look relatively normal. Where's my mouse? There it is. Relatively normal, something like that. We go through the months. And then one month, it's all the way down here, suddenly back to normal. That doesn't look right. Let's say you go audit it. Sure enough, you see the manager or whoever is embezzling money out of it because they need it. These types of things can give you a pretty good idea if something bad's going on. So as we go through this lecture, not only will I teach the measures of location, but you'll be able to use these to hopefully see, like if you're on the job or whatever you're doing, if there's something pretty sinister going on that you don't like, these will often be your first indicators that it's happening. So if that's said, we'll go ahead and get started. And here, get ready for a lot of definitions and formulas all in a row. So we'll start with the average and the median. The other word for average, which is the word that we are going to be using, is called the mean, M-E-A-N, like, oh, this is a mean person. And the mean, it's the same thing as the average, but we're going to use the term mean for most of this course. Now, the formula for the mean, and it's one that y'all all probably know, but I'll write it down anyways. Our mean is equal to the sum of our data values, divided by the size. Now notice I put size and not sample size. You'll see why in a moment. So, for example, in an extraordinarily simplified case, let's say we had 3 people in a class. One got a 70, one got an 80, one got a 90. Add those together, 70 plus 80, 150. Add the 90, 240. There's 3 of them, divide by 3. You get an average of an 80. That's an extraordinarily simplified case, but I imagine most of y'all are already rather familiar with that. Now, the new thing I'm going to introduce to you here with regards to mean is there's actually 2 types of means. They're both calculated in the same way, but they have different data. The first one is what we call the sample mean. Now, it's calculated in the same way, but we denote the sample mean as X bar. Now, as a note, typically y'all are all pretty familiar. When you work with algebra, your independent variable is always X. That's why I say X bar. But for a study, it might not be X, it could be D or even G. Let's say G are your grades. You have all of these G's, and so you might say G bar. Point is, whatever they are, you have the bar at the top. Now, the other one, we have the population mean. So we will denote the population mean as the Greek letter mu. So if I say the mean is mu, we're referring to the population. If I say the mean is X bar, whatever X bar is, we're dealing with a sample. This is why I said size and not sample size, because we don't know what mean this is. If it was X bar, it would be sample size. If it was mu, it would be the population size. So this is a bit of notation we have here. Now I'm going to introduce you to a couple of other notations. One of you may have seen before. The other one you probably almost certainly haven't. The first one is called summation notation. How many of you have heard of that before? No one in class raised their hand. We denote a summation with the Greek letter capital sigma. Looks like that. So for example, let's say we had, going back to that extraordinarily simplified example, we had 70, 80, and 90. We could write down 70 plus 80 plus 90, or we can write that down as the sum of 70, 80, and 90. And I might say, okay, that saves us no space. Well, sure. But something else, let's suppose we call our 70 G1. Oh, that's a goofy looking G. Let's try again. G1. We call the 80 G2. And we call the 90 G3. We have 3 data points. We can call these GI for some value of I, where I is whatever data point we have. So we have 3 data points. I can be 1, 2, or 3. Then we could therefore write this as the sum of GI, our 3 GIs, 1, 2, and 3. And therefore, since this is a sample, just to give you a little bit of a recall from something said a few minutes ago, we can call that G bar, our sample mean of these 3 grades. Yes, someone raised their hand, Victoria. Victoria, you raised your hand? Yes, well, GI, if we say the sum of GI, we're adding up all of our G values. Any individual GI could refer to one of our data values. You don't know which. Now, if we were in calculus, I would say the sum from I equals 3, I'm sorry, from I equals 1 to 3 of GI, but this isn't calculus. We don't have to do that. So when we say sum of GI or XI or something I, what we're basically saying is the sum of all of those values. Now, you might say, why would we do that? I see no point in that. Well, if we go back up to our formula, we can rewrite our mean for our sample mean, or really for that matter, it can be anything. We can write that as the sum of our values. And here I'll put xi to stay consistent. Sum of our xi's divided by our size. Oftentimes for size, we have either lowercase n or uppercase n. As convention, lowercase n refers to sample size and uppercase n refers to our population size. I'll give you a moment if you wanted to write that down. That's more so something I say instead of write down. But you'll notice that if you go through and look at the textbook formulas, you'll see they make that distinction. So before I continue, are there any questions with regards to this notation I've introduced? Yes. What do you mean by that number? Like the sum. You always test the number. Yes. Oh, for those over Zoom, the question he asks is, if we have G bar, does that refer to the numbers? That's what you said? Our G bar is the average of those numbers. That's formally what G bar means. So in this case, G bar would be the average of those grades. So in effect, so for here, we can say this is equal to X bar. Now, on the other hand, if it was all of the grades, then we would say mu. So the goofy looking U. Are there any other questions with regards to the notation we've introduced so far? All right, there's one other bit of notation. This one I am very sure no one here has seen before. It's not used all that often. It's called product notation. So I'd say, what's product notation? Well, let's suppose, how many of you all have heard of a factorial before? You know, like 1 times 2 times 3 times 4. Yeah, those people in class. You can write that in product notation. Now, formally, they just put an exclamation point. So for example, if I say 5 factorial, we all know that's equal to 5 times 4 times 3. You don't have to write this down. You don't have to write this down. Times 2 times 1, which is equal to 120. However, factorial only goes down in integer order. What happens if they're not all the integers 1 to 5? What if it's 1, 3, 5, and 7? Can't denote that with factorial. So what do? And what happens if you have 100 of them? What if we have all of the odd numbers from 1 to 201? Can't use factorial for that. What do? That's going to take too long to write out. We use what's called product notation, and we will denote product notation as this. And some of you have seen this before. Oh, yes, sorry, I didn't see that. Sigma, yes, sigma gi, yes, the sigma of gi divided by our size. So notice it's, I'm sorry, I made a mistake here. I'm sorry, I made a mistake here. Divide by size, I apologize. There we go, sorry about that. I forgot the size. Let me correct that. So if you wrote that down, I forgot to write down the size. Thank you for pointing that out, Kylie. Yes, the sum of all of our G values is multiplied. I'm sorry, multiply. I keep getting it mixed up. I am sorry. Multiplied by size. There we go. Because we had the divide on the left, so we multiplied to clear that out. There we go. So the sum of all of our G's is our G bar times our size. That is correct. Everything else holds. Everything else same as before. You'll note that in the notes that I give you that I have right here, this isn't even on there. Yes, and the sigma is the sum of all of those values. So when we say sum of GI, we're adding all of our G values together. Or it could be X values, doesn't matter. Like if we're dealing with student evaluation scores and 60 of you provide evaluations, and let's say there's, I don't know, 22s, 24s, and 23s. We would add up all the 2s and all the 3s and add the 4, all of the 4s. So that would be the sum of all of what we might call, I don't know, E's, or whatever you want to call those. S's, doesn't matter. So here, going back to product notation, that's technically, that's capital pi, technically speaking. That's why it looks slightly different from lowercase pi. If you know, lowercase pi looks like that. So slight difference, but as a practical matter, you just need to, you don't have to write that down. You just need to know what the uppercase one looks like. So technically those G values, we could multiply them all together. And we would denote that. So let's say we had 70 times 80 times 90. So this example back from over here. We could denote this as big pi, so capital pi, of GI. So we can denote the product of all of our data as capital pi of the GI. The main reason why we do this is because y'all will see when we start getting into some of the data, especially like, you know, with all those grades, the motivating example, if we wanted to multiply all the grades together, there's 100 of them. We can write that all out, but it's easier just to write this down instead. It saves us some time and paper. So this is the last bit of notation before we really start getting into the formulas. Any questions about notation? People on Zoom, any question about notation? All right. Now, so the example there, this mean, that's technically your first formula. Our next one, we have the median. One of two things happens with it. The formal definition of the median is the halfway point. So with the median, the first thing you do, no matter what, you take all of your values and you sort them from lowest to highest. So for example, the 70, 80, 90, that's already in order from lowest to highest. On the other hand, if it said 80, 90, 70, you would first have to sort that as 70, 80, 90. Connor, I'll show you when we use the pi thing in a moment. That's a bit later on for one of our formulas. I just figured I'd show you the notation before actually getting into the formulas. Now, here's the issue. What happens if we have an even amount of data? Let's say we had 70, 80, 90, 100. That's an even number. What's the halfway point? Well, here's what we do with the median if we have an even amount of data. You still put them in order. The first step is always the same. No matter how much data you have, whether it's an even amount or an odd amount, you always put it in order from lowest to highest, or you can do highest to lowest, just as long as it's in order, ascending or descending. I recommend descending. You'll see why later. So you put it all in order. If you have an even amount of data, you take the 2 points right in the middle, and you take the halfway point between them. So for example, we have 70, 80, 90, 100. The two ones in the middle are 80 and 90, halfway point, 85. So that's how you do the median. So very formally, if we want to go as formal as possible, this is going to be a lot of typing, or a lot of writing, so I'm just going to pull out the typing, save us a little bit of time. This should be big enough. Let me make this box bigger. So for our median, first, sort the data in ascending order or increasing, call it whatever you want. Then you're going to do one of the following two things. If we have an odd amount of data, so if we have an odd number of data points, or well, I'll just say data, then the median is the data point in the middle. I'll give you the extraordinarily formal definition in a moment, but I just want to have this written down here for those of you that like writing down notes, which is perfectly fine and is a good thing. If we have an even number of data, then the median, that's 10, not then the median is the mean. Remember, we just had the definition of mean first, that's what you'd mean first, is the mean of the two data points in the middle. Make that a little bit wider. You could say midpoint instead of mean, doesn't matter, just two data points. So if you have two data points, the midpoint and the mean are the same thing. So I'll give y'all just a moment to write that down, since it's a decent bit to write. Now, the extraordinarily formal definition, and for here, I'm going to use lowercase n. We can use capital, doesn't really matter. I'm just going to stick with lowercase here because usually you'll be dealing with the samples. We usually don't care about the population median unless it's something like grades where you want to see if you have that measure of difference. So the extraordinarily is about as formal as you can get. What I just said in A is the same thing as saying the median in this case would be the n plus 1 over 2 data point. So for example, just again, with the extraordinarily simplified one for the purpose of explaining the concept, we have the 3 grades, there's 3 of them. N is our 3 plus 1, 4 divided by 2, second data point, which is the 80. So for those of you that want to have it as hard and straightforward as possible, that is about as formal as you get. Let me move this down just a little bit to give it a little bit of space. I'll scroll back up. Now, for an even number of data, about as formal as possible, it is the mean of yes, that's n plus no. So that n plus 1 is all in the numerator. It's not n plus 1 over 2. It's n plus 1 all divided by 2. So I'll just type it in chat for those at home. There you go. Don't mess up those parentheses. Because if you do n plus 1/2, you're going to be outside of your bounds. You're going to be way off the middle of nowhere. So anyways, keep going. It is the mean of the n over 2th and n over 2 plus 1 data points. Okay. Right here, that's just like th, like, a fourth, fifth, it's the th at the end. So I'll try to make that a little bit clearer. So either that h did come right next to the d. There we go. So for example, when we have the 70, 80, 90, and 100, that's n equals 4. 4 over 2, that's 2. And then we have 4 over 2, which is 2 plus 1, that's 3. So second and third, the 80 and the 90, halfway 85. That makes sense with what we personally know. Pick whichever definition is the easiest for you to understand. Some people, you're more so vocabulary word, you just like the word definitions. Some people are very, you want to have it as formulaic as possible. And others, it just intuitively makes sense. Pick whichever one's best for you. Now, with that said, we'll do a quick practice problem. Let me see where it is, because we got a lot of practice problems we can work on here today. Here we go. This one right here, th, like for example, we have, let me pull this up, like, fourth, fifth, sixth, so on and so forth. That's what the th means, because our n is going to be an integer. You can't have half of a data point. So if we have n equals 5, then we have the 5 plus 1, which is 6, divided by 2, that's 3. So I guess you could say 3rd, but we all know that's third. But that's the general idea of it. Generally speaking, you'll be dealing with sample sizes that are much larger than 3. So here, let me move this out of the way. Couple of quick, let me just get this out of the way. It's not a big deal, because that's just repeating itself. Here we go. Couple of examples. I will give you about a minute or two to work on these. If you have a calculator, you can use your phone if you want, mostly because the Proctorio will give you a simple calculator. Again, you'll see why I say no graphing calculators. The graphing calculators will calculate this for you. So that's why on the Proctorio exams, no graphing calculators. You can use a scientific one, or you can use the Proctorio calculator. You can't pull out your phone, because if I let you pull out your phone, you're just going to Google it. You could Google the answer. So a couple of these here, I'll give you a minute or two to work on them. And then we'll continue. I'm going to move this down just slightly so we have some extra space to work with. There we go. Something you should note, they are not ordered. So with both of them, you got to order it first, or you should order it first. Yes. Pardon? Because, so here it says n equals 5, that's our sample size. We have 5 data points, 9.2, 6.4, 10.5, 8.1, and 7.8. So that's why it gives you the n. Technically, it didn't have to give you the n, but I don't think I need to assess you on how high you can count. I'm pretty sure you can all count pretty high. So save you some time. So the reason why you do it in ascending order is because the definition of the median is based off of that. If you don't have it in ascent, technically you could find the median without it being in ascending order, but that requires you to have practiced it for quite a while. All right, give an extra minute and then we'll go through the two answers. Now, for those of you, whether at home or here right now, if you're using your phone as a calculator, like I said, that's fine. What I'd recommend doing is if you don't have a scientific calculator, I'd recommend going to the Sudoku bonus exam. You don't have to take it, just like, load it up and then pull up the Proctorio calculator so that way you're at least familiar with it. All of the math I ask you to do, you can do it with a nice and simple boring calculator. I'm not going to make you do a ton of extraordinarily annoying fractions and simplifications. I'm not saying there won't be simplifications. I'm just saying, I'm not going to give you 10 fractions that are all ugly. Say, add them all together, get the greatest common denominator, group them all into one, then simplify. We're not going to do that. You might have to do a little bit of simplification. There's simplification in all math courses, but I'm here to see if you know the material, not how good are you with simplifications. This is a statistics course, not an algebra course. Seems like we still have a couple people in person still writing things down, so I'll wait for maybe an extra 20 or 30 seconds. I don't know what a TI 30X looks like. Let me see, Megan. I believe the TI 30X should be fine. Yes, I'm about to show you ordering stuff. Is there anyone in person needs any more time? All right, we'll go ahead and get started. We'll start with the first one. Yes, the Proctorio calculator will be enough for the test, yes. So we got to put them in order. Here's how I recommend doing it, just to pretty much make it as least likely as possible you accidentally make a mistake. Look at the data points. What's our lowest data point? Someone can just shout it out, I don't care. 6.4. So we're going to write down 6.4, put a comma, scratch it out. We've already used it. Next lowest. 7.8, that's our next lowest. So you write down 7.8, put a comma, scratch it out. Next lowest. 8.1, put a comma, scratch it out. And I think it's pretty clear the next lowest one here is 9.2. Put a comma, scratch it out. Our last one is 10.5. These do not look like commas. Let me make this more obvious. Oh, whatever, I'll just delete it. There we go. So our sample size is 5, halfway point. It's pretty obvious. Now, here's another way you can do it. If you're a very visual person, here's another way. Just start scratching things out on the left and the right. So the way you can do it, you can get rid of the far left and the far right at the same time. So exactly, scratch it out, scratch it out. Now don't do it one at a time, do them in pairs. Because if you scratch out the 10.5 first and then the 6.4, but we had 6 of them, you'd make a mistake and do the third one. So do it in pairs. So 10.5, 6.4 out. Next one, 9.2 and 7.8 are the new ones on the far left and the far right. Scratch them out, gone. We're left with one data point, 8.1. That's our median. So this is the visual way of doing it. 3 ways of doing it. Verbally, very mathematically, or visually. Pick the one that's best for you. They all work. Now the mean, we just add them all together. So I'll just pull up my phone calculator here. I already know it's 42, but we'll just do them anyways. So if you have your phone calculator, that's a clock. We have our phone calculator. We have our 6.4 plus our 7.8. Even better, this one might have a calculator, because I'd like to at least show y'all what I'm doing. I know those of you at home, I can't screenshot the calculator and the paint at the same time, but at the very least, the people here, y'all can see it. So we have 6.4. Why is the num lock not on? There we go. 6.4 plus 7.8 plus 8.1 plus 9.2 plus 10.5. 42. Now, that is our sum. We have to divide that by our sample size, which is 5. Divide by 5. So our mean is 8.4. That makes sense? Now, spot check. Well, these are birth weights. We'll call them B values, BIs and whatnot. Is this mean, should we call our mean mu or should we call it B bar? How do you think we should call it mu? I think we should call it B bar. That's correct. Half of you didn't seem you wanted to answer. That's fine. This is B bar because it's a sample size. It's obviously, these are not all of the babies in the US. If they were, then the country would be screwed. So here, I'll write it down here. We have B bar is equal to 8.4. So that's our first one. Let's now do the second one. Notice we have n equals 6 now. When we start the median, process exact same. Put it in order. Our lowest data value. 3, there we go, that's our first one. Put a comma, scratch it out. Next lowest, 15. And we'll just keep going. Next one, say 36, 46, yes, 46. Scratch it out. Next one, 64. Last two, it's pretty obvious. 126, scratch it out. 623. Now, if you want to do the visual method, we can scratch out far left, far right. Keep doing that until we have 2 or less. Now, if you wanted to use the formal definition, we have an n of 6 because there's 6 of them. So we have the 6 divided by 2, that's 3. So third data point, which would be 46. And then we have the n over 2 plus 1. So 6 over 2, 3 plus the 1, that's 4. Third and fourth, that's 46 and 64. Let's verify that and do the nice, good, hard, true, and tested visual method. Far left is 3, far right is 623. Again, do them both at the same time. Maybe, can I write them at the same time? Touch screen's not on. Whatever. So now, if you have 2 pencils, you can do that if you want, doesn't really matter, as long as you don't do both at the same time. Next 2, the newest far left is 15, newest far right 126. We can't scratch out these 2 because then we have no data. This is another indicator. You take the halfway point. So we take 46 plus 64 divided by 2, which that's 110. Then you divide that by 2, 55. So to write it out here, we have 46 plus 64 divided by 2. 46, you should be able to do this in your head. Add the 450, add the 60, 110, divide by 2. That is 55. You'll notice this median is not one of our data points. It is possible for the median not to be a data point. Now, let's suppose, before we go to the mean, let's suppose instead of 46 and 64, we had 80 and 80. You can just stop there. Technically, you can take the average of 80 and 80, but that's going to be 80. So you just stop there. So sometimes, usually, the median will be one of the data points. Sometimes it might not be. Now, our mean, we just add them all together. So I'll pull up the, and again, for those of you at home, you can't see it because it won't let me share 2 things at the same time. At least I'm not aware of it. Let me move the chat out of the way. So let me clear. So 3 plus 15 plus 46 plus 64 plus 126 plus 623, 877. Sample size is 6. So we divide by 6. Our sample mean is 146.166666666. You'll notice I said sample mean. This is a sample. Now, we don't know what these data are. If the data don't have units, we just use X. So here, we would say X bar is equal to 146.167. On the assessments, on web work, and on the exams, you round it to 3 decimal places. If you want, no, I don't have a camera. No, because I'm sharing the screen. If you want, if we have, in that case, you could have written down 146 and 1/6. That works too. I don't mind. You could have written down 146 plus 16. Yeah, those of you at home, let me see if I can share the calculator with you. Let me share the calculator with you for those at home. It'll stop sharing for a moment. Let me share calculator. Can those of you at home see the calculator?
Yes.
All right. So now, let me clear this. We have our data values. We start with our 3. And here, again, I can't show you both at the same time, but you have it in front of you because you wrote it down. We had our data points. Our lowest was 3. We add the 15. We add the 46. Add the 64. Add the 126. Add the 623. That's the sum of our data values, or we call that sum of our xi. Now we have to divide that by our size, which is 6. So we divide by 6. That's where 146.166666666 comes from. So I'll switch back to the whiteboard now. All right, you bring the chat back up so we have. All right, so that's that example. There's one more thing, and these are called measures of location. There's one more measure of location. It's the easiest one of the 3. It's called the mode. Our mode is the most common data value. Oh, that's not how you spell common. Now, there's a very important note. In order for there to be a mode, that whatever that value is, it has to occur at least twice. So I'll just type this, save us some time. So the mode has to happen at least twice. So in our example above, we had the 3, 15, 46, 64, so on and so forth. None of the data points occur at least twice, so it does not have a mode. Now, here's a question I'd ask yourself. What if our data was 50, 70, 70, 90, 90? What do we do there? Do we have 2 modes? The answer is yes. You can have multiple modes. If you have 2 different data values that both occur more than once and occur with the same frequency, then you have 2 modes, or it could be more modes. We call that bimodal. Lo and behold, when I showed you all that bimodal before, that's what that means. Now, technically, we could have 3 modes. That's trimodal, 4 modes, quadrimodal, so on and so forth, but you don't have to worry about that terminology. So, case in point, with the mode, most frequent value has to occur at least twice, and there can be more than 1 mode, assuming that those 2 modes occur with the same frequency and or at least twice. Now, as a note, let's say we had 10, 70, 70, 90, 90, 90. Even though the 2 70s occur twice, that's not most frequent. 90s are most frequent, so the 90 is our mode, end of story. Now, when dealing with getting the mode, I recommend ordering your data. Just like with the median, put everything in order. Now, with that one, you can go in descending order. I recommend staying with ascending order just to keep it consistent. Now, technically with the mode, you do not have to have all of the data points to know what the mode is. Let's go back to our starting example. You don't know what the exact numerical grades are. Those 16 people from 70 to 80, for all you know, it could be 71, 72, 73, so on and so forth. Here's what you do know though. Let's suppose we say 90 to 100 is an A, 80 to 90 is a B, 70 to 80 is a C, standard grading scale. In that case, what would the mode be? How do you think the mode would be in F? D, C, B, A. In this case, our mode would be the B. So you don't have to have all of the data points to know what the mode is. That's why when we had our graph like this, we called it bimodal, because we had 2 peaks, 2 modes. So if you're given a graph, it can be a histogram, it can be a pie chart, If they ask you for the mode, it's basically saying in which range is the most common mode. Here's a catch to that. Let's suppose, because remember that question I gave you, I said what letter grade was the mode. What if I said what numerical grade is the mode? You don't know the answer. Some people might say, oh, 85. 85 is the halfway point between 80 and 90. 85 is the mode. You don't know that. For all you know, it could be 1682s and 1787s. You have no idea. So if I said, what is the numerical mode? You don't know. If I say, what's the letter grade mode? Then you know. Does that make sense? You will see that on the assessment. You need to be able to make that difference. So if you're given a graph and we ask you for the mode, you need to figure out categorical or quantitative. Because notice when I said A, B, C, D, F, that's categorical. Another note, technically, you can find the median with categorical data. Now, the mean, not necessarily. If I just gave you this graph and said, what's the mean? You don't know. You can make a good guess. You don't know for sure. You can get the median from this graph. Or at least you get a good location of the median. So I say, how do I do that? Here's how we do it. Just looking at this graph, we can make a pretty decent guess that our median is going to be somewhere between 60 and 90. You might say, why? Because that's where most of the data is. Pretty good guess is the median is going to be somewhere near where the bulk of the data is. So the stuff to the left of 60 is 3 plus 12, 15. The stuff to the right of 90 is 23. Everything else in between is more than both of those. So we know the median is going to be more narrow than that. Let's make a guess. Let's assume that the median is between 70 and 80. Let's add up everything before 70. 3 plus 12 is 15. Add the 21. That's 36. The stuff to the right of 80 is 33 plus 23, 56. 56 is much more than 36. Even if we added that 16 to the 21, 12, and 3, 16 plus our, what was that, 36 is 52. 52 is less than 56. Therefore, we know the median has to be somewhere between 80 and 90. We don't know exactly what it is, but we can at least narrow down the actual numerical mean is 80 to 90. However, we know for sure if the median has to be between 80 and 90, then the median letter grade has to be a B. So if I ask you, what's the median letter grade? You can say B. If I say, what's the numerical median? You don't know. You can give me a range where it is, you don't know. Again, for that assessment, it'll ask you that. It'll ask you, what is the median of this graph? If it's a categorical median, based like, what's the median letter grade? You can answer that. If it's a numerical one, no, you can't. You'll notice figuring out the median of a graph is a little bit difficult. It's a little bit of a trial and error thing. You make a guess where the median is, and you add up the stuff to the left and the stuff to the right. Now, for example, let's say that 33, let's instead say, or even better, let's suppose all of this didn't exist. Let's say all of those 90s didn't exist at all. Well, everything to the left of 70 was 36. Everything to the right of 80 was 33. If we take that 16 and add it to either of them, we go over that threshold. Basically, what we add the 16 to decides which one's bigger, therefore the median would be in there. So if we throw out all those 90s, the median drops to the 70s range. I know that was a little bit tricky. Are there any questions about that? Yeah? Pardon? Here, let me, something we should probably try is see if you can speak with the microphone. Can you pass that back? Sorry, for those of you at home, someone has a question, they're a little bit further back.
Can you hear me? No.
Yeah, when you're speaking, you're socially distanced. You can pull your mask down when you speak.
Okay. So I'm asking if there's a question on the exam and it's asking which of this is a numerical medium of the graph. Do we have to calculate it, or is there going to be an option that says not none of
For
the
the
above?
mode, there's no calculate. So for on the exam, if I ask you for the median or the mode, this will be multiple choice. It'll be one of two things. Everything's going to be like a letter or a word, or everything's going to be a number. Here's a big hint. If I ask you the median of this graph, and your four answer choices are 55, 65, 75, and 85, all of them are wrong. Every single one of them is wrong because those are numbers. You don't know the numerical median. On the other hand, if the four choices were A, B, C, D, you would know it's a B. Now, if you see the numbers, what it'll do, it'll give you 3, and then it'll say not enough information to tell. Likewise with the letters, it might say not enough information to tell. So if you see an answer choice that says not enough information to tell, that doesn't mean that's the correct answer. That means you got to think for a second, okay, can I definitively say this is where the mode is, this is where the median is? Now with regards to calculating, the mode, there's no calculating. The mode, we should look for the highest bar. So if I say, what is the mode letter grade? The highest bar is 33. That's in the B range for at least a standard letter grade scale. So that would be that'd be a B, end of story. No calculating there. With the median, it's a little bit of guesswork. But again, you know the median's going to be where the rest of the data is. Even if our graph looks like this and has that big, long, nasty tail, the median is still going to be around that height. You can't have a median. It depends what you have. For this graph here, the letter grade, you know the median. The numerical one, not necessarily, because you don't have the actual data. If I gave you all of the grades, you can get the median, easy. If you don't have all the grades, you can't get the numerical median. You just can't, because you don't know where those data points are. That's the nature of a histogram. So, long story short, nice little rule of thumb. If you're given a graph and it asks you for the mode or the median, it's not going to ask you for the mean. It's not going to do that. If it asks you for the mode or median and just gives you the graph, first question you have to ask yourself, is it asking me for a categorical mode or categorical mean, i.e. letter grade or pass-fail? Or is it asking me for a numerical mode or median? If it's numerical, no, you can't answer. If it isn't, if it's categorical, you will almost certainly be able to answer. The only time you wouldn't be able to, let's say exactly half of them were to the left of 80. Let's say 50 of them were to the left of 80 and 50 of them were to the right of 80. Then, even then, you couldn't get the median letter grade. Because, for example, let's say our two middle points, one of them could be 79, the other one could be 83, in which case the median is a B. On the other hand, you could have 76 and 80, in which case the median for that class would be a C. With the mode, basically long story short, very long story short, with graphs, if I ask you for a mode and it's numerical, can't answer. If it's the mode and categorical, you will pretty much always be able to answer it. If it's median and numerical, you pretty much can't ever answer it. If it's median and categorical, you will almost always be able to answer it. There's technically a very small chance that you won't be able to. But I'll tell you right now, I'll be nice. On the assessment, it's not going to do that to you. If it asks you for a letter grade median, there will be a letter grade median. So, I know it's a bit tricky. This is one where I should give you a practice one to work with. So down here, we have a practice example. First, and here we'll save you some time, we've ordered it. Here's an order, figure out the mode, and then the pie chart, find the mode. Additionally, I'm going to add an extra one since we talked about it. Find the median. And with here, note, we will assume freshman is less than sophomore is less than junior, is less than senior. So we'll make that assumption. So do those three, and then we'll talk about it at 7. Oh, sorry about that. There you go. Move that down here. There we go. All right, is there anyone who needs more time? All right, we'll start with example 3, the mode. We'll just go in order. How many think it's 0? 1, 2, 3, 4, 5, 6, 26. It is 3 because we have, I think that's 5 of them. Now notice 2 and 0 are both repeated twice. Doesn't matter because 3 is repeated 5 times. So that's our mode, end of story. So our mode is 3. Let's go this one. This is the graphical one I imagine we need to think about for a moment. The mode. We'll start with the mode because that's the easier one. Again, note this mode. Well, I'll phrase it this way. How many of you think that there is a mode? How many of you don't think there's a mode? There is a mode because we don't care about their ages. We just care about their classification. This is categorical, so there will be a mode. So now, we'll actually do them. How do you think the mode is a freshman, junior, senior, sophomore? The sophomore, because 46% is well higher than the next highest, which is 30%. Now the median. How many of you think there is a median? How many of you don't think there's a median? There is going to be a median with this one. I'll explain why in a moment. So now the median itself. How many of you think the median is a senior? Junior? Freshman? Sophomore? It is sophomore. And here's why. Here's why sophomores are median. We're looking for the halfway point. We don't know what their exact credit hours are, but we know for the median, we put them in order. So we know all the freshmen are less than all the sophomores, which are less than all of the juniors, which are less than all the seniors. Here's what we know. Freshman is 10%. 90% is way higher than 10%, so it can't be the freshman. Now let's add our 46. 10 plus 46, that's 56. A majority of our data is contained by freshmen and sophomores. So therefore, the median has to be in there. It can't be freshmen, has to be sophomores. Notice that thing we just did. You remember we talked about the ogive. The ogive was a graph of our cumulative data. So in a sense, we can make an ogive of this. Let's make an ogive. We'll call that freshman, sophomore, junior, and senior. That'll be 25, 50, 75, 100. Our freshmen are right about here. It's only 0.25, 0.5. Mouse is a bit wiggly right now. 0.75, and then 1. This is percentage. When we always start at 0 and we go to 10%. Now, all of the people who are sophomore or less is 46 plus the 10. Now we're all the way up at about 56. I'm sorry, it's not perfectly straight. Now we go there. Our juniors, we add the 30 to that. So 30 plus 56 is 86. That's going to be maybe, I don't know, here. Sorry, it's not perfectly straight. Then our seniors, that's everyone, 100%. Making an ogive makes it much easier to figure out the median of categorical data. All we do, we go from left to right until we go past 50. If we go past 50, the one that puts us past 50 is our median. So here, just looking at that, sophomore puts us past 50, so they're our median. Now remember, we went in order from lowest to highest. This is another reason why it's preferable to do lowest to highest. Technically, you could have gone in reverse and still gotten sophomore, because sophomore would have put you below 50 because you're going in reverse. But this is another reason why it makes more sense to go in increasing order. So our sophomore is the mode and the median. You'll note as we go through some other examples, it is entirely possible for multiples of these to be the same. The mode can be the same as the median. That's entirely possible. The median can be the same as the average. The average can be the same as the mode. They can all three be the same. Just depends on the data. For any questions about that, for those in person or for those at home? All right. Now let's get to an easy calculation. About the easiest one you will see in this entire course. It's called the range. The range is the biggest minus the smallest. That's it. So I'll write that down over here. Range equals biggest minus smallest. That's it. That's all there is to it. There's nothing else. You'll see that's about the easiest calculation in the course. So, as an example, let's go back here. For this array we just had, for the range, our biggest is 26, our smallest is 0, 26 minus 0, 26, that's our range. Easy as that. That, yet again, is another reason why you order your data. It's, again, easier to go lowest to highest because take the one on the far right, subtract the one on the far left. And if we go up here, the range of this, 10.5 minus 6.4, 4.1. All of those are, generally speaking, the most common measures of location and spread for data. Now we'll get to a couple of special ones. One of them is called the weighted mean. And this is where I kind of have to use a summation notation, is the sum of the weight of any data point in question divided by the sum of our weights. I understand that's probably a little bit confusing to look at. Think of it this way. Remember the syllabus quiz? It asked you to calculate your assessment exam score. We had the policies at 4%, everything else, the other four were 19. So our 5 weights were 4%, 19%, 19%, 19%, and 19%. So we would multiply the 4% by the policy score, then we would add the 19% times 100%, and then so on and so forth. And then we divide all that by our weight. I imagine a lot of you are thinking, oh boy, wouldn't this have been nice to know for the policies assessment? That's why there was a little bit of a curve on that. So our weighted mean, here's what we do. And this one might make it a bit easier to see. We'll just deal, the denominator makes sense. You should add up all of your weights. That's pretty straightforward. Think of the numerator as this. We have our first weight times its associated data value. We have our second weight times its, yes? Oh, okay. So our second weight times its associated theta value. Again, this is another reason why order matters. And then we have our third weight times its associated theta value. Keep on going until we get to our final one, our nth weight, which is our last weight, times our last data value. That's what that summation means. The textbook just puts it like that. I don't think that does a good job of explaining it. That's why we write it out like this. So this definition should make it much easier. Yes. Pardon? So weight is how much importance that something has in the average. For example, our syllabus, the assessment you have on the 16th is weighed much more than the policies assessment you have. And effectively, all of your grades are weighted averages. That's what they all are. Every class you take, everything's a weighted average. Now, sometimes in the English classes, everything's a quarter each. So, I mean, technically it's a weighted average, but you really just call it an average. On the other hand, in most other classes, not everything is weighted the same. So, weighted average. Technically, that mean we talked about, the mean is also a weighted average, except everything has the same weight. So really the mean is a special case of the weighted mean. So I figured I'd show y'all the formal definition of that. Now we'll do a very quick and hopefully easy example of this. This might be some flashbacks for some of y'all. Let's see where it is. It's somewhere in here. For half of you, this will look very familiar. So for those of you that had this, you can give it a second try right now. For those of you that didn't, you can give it a try. This is straight out of the policy assessment. Again, this problem is why I gave the curve, because even though you can figure it out, I understand if you didn't. That's why we have the curve for this. Yes, I can go back to it. Hannah, let me know when you're good. Hannah, is that good? All right, we'll go back to the example. The definition of the weighted mean, we take each weight and multiply it onto its associated data point. So our first weight times the first data point, plus the second weight times the second data point, so on and so forth. So for example, in our one up here, our first weight is 4%, and the first data point is the 50 that he got. Our second weight is the 19%, and that associated data point is the 60, so on and so forth. Again, when you're done getting that whole big sum, don't forget to divide by the sum of the weights. I'll give you a minute or two to work on this one. Yes. So when you are doing the interim, you never round until the very end. Never round until the end. So if you have 17% times a third of a percent, you multiply them together, you do not take off any of those decimals until the end. So never round until the very end. Does anyone need some extra time? We have a couple people in person. I'll give you an extra minute. What's probably going to happen is the variance and standard deviation we'll do next lecture, because we have a couple of extra logic problems that we want to work through before class ends today. We might go a little bit past the ending time, but thankfully there's nobody here after us. So if you want to leave, you can leave. If you want to stay, you can stay. It's up to you. I just don't want to hold you forever. All right, is everyone good to go? All right, we'll get started. So we'll use the whole big formula. Our first weight, what is our first weight? Something just yell it out. 4%. I'm going to write that down as 0.04. You should get in the habit of using decimals anyways. And what is the data point that is associated with that 4%? 50. I'm going to write that down as 0.5. So that is W1 times X, or we'll call that G1, because these are grades. Let's stay with G. Now, what is our next weight? 19%. I'm going to write that down as 0.19. What is the data point? What is the grade associated with our first 19%? 60%. Notice we're just going in order. So 0.6. Now, just save us some time. Our next weight, we still have 19%, so 0.19. Our next grade is 70%, so 0.7. Move over a little bit. Our fourth weight is still 0.19, and we have 80%, so 0.8. And then our final weight, move the chat a little bit, is still 0.19 times our 90%. Now our denominator, we add up all of our weights. So our weights are 0.04, 0.19, we're going in order, 0.04, 0.19, and then we have three more 0.19s. 0.19, 0.19, 0.19. Before I begin simplifying this, does it make sense what happened here? Since no one said no, I'll assume everyone's fine. Now from here, I would recommend doing all of the multiplication in the top first and all the adding in the bottom before you add up everything in the top, because some calculators don't like doing everything at once. So 0.04, oh, what is this thing doing? 0.04 times 0.5 is 0.02. So 0.02, that's the product of these two. We have 0.19 times 0.6, that is 0.114. Then we have 0.19 times 0.7, which is 0.133. Then we have 0.19 times 0.8. I'll make that look a bit more like an 8 for you. And so this is 0.152. And then we have 0.19 times 0.9, which is 0.171. Now the entire bottom, you should put those 4.04 plus 0.19 plus 0.19, blah, 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 into the calculator. Your bottom becomes 0.8. I guarantee you there are many people on the policy assessment who got the top right, forgot the bottom. And that's understandable. Again, that's why there was a curve. Now from here, you should add up all the top. Once you're done, divide by that bottom. So we have 0.02 plus I think that's 0.114 plus 0.133 plus 0.152 plus 0.171. That's 0.59. Now we divide by 0.8. That is 0.7375, which is what is on the key. So this whole thing simplifies down to 0.7375. But we want to put it in percent form. We recall to go to percent, move decimal 2 places to the right, or multiply by 100, and add the percent sign. So the 0.8, we added these numbers up here. We added those up, Brandon. That makes sense? That 0.8 comes from adding those 5 numbers up. So we have to put that 73.75%. And that is our weighted average. Now, Blackboard calculates this for you. As far as I'm concerned, you've technically already been assessed on it, so this shouldn't be showing up on the assessment. Might show up on the web work, but thought I would show you. Let's see how much time we have. Okay. This is a definition. You're not going to be assessed on it, to my knowledge. I'm going to give you it anyways. We have something called the geometric mean. Yes, the policy assessment answers are on Blackboard, yes. The geometric mean is equal to the product of all of our values. So remember that product notation? Here it comes back. There's that product notation again. And then we take the nth root of it. You might say, what's the nth root? I don't know what that is. That's the same as raising it to the power of 1 over n. So you can think of this as this product of xi to the power of 1 over n. Same thing. This just definition, you mainly see this in stock markets and whatnot. This is expanded on, this is expanded on much more in the quantitative theory of interest. I will leave that there. Just giving you the definition just so we can say we covered it. But if you want to write it down, it's up to you. I just figured I'd show you it anyways. Now, sample variance, sample standard deviation. Essentially, we have that, which I wanted to cover today. We also had a couple of logic problems I want to cover. We'll cover the logic problems. So if you want to leave now, you can. It's up to you. It will show up on the exam, though. What I will do is, if I can, I'll take the last 10 minutes and post it, but I can't make any promises on that because that's a bit trickier. If I can, I will. But if you need to leave now, you can. I'm going to do the logic stuff because that is very closely related to what I've already shown you. It is going to show up on the assessment. I guarantee it. It's going to show up on multiple problems. So, long story short, variance, standard deviation, we'll do that next time. Logic problems, we'll do that now. Hopefully, it shouldn't take longer than 10 minutes. So, you recall when we did the stuff from chapter 2, when we were doing the graphs, I gave you the stem and leaf, and we went backwards, get the data back. We can do the same thing here. I can give you, mean and median, range and mode, or that kind of stuff, and say, okay, go backwards, find the data points. So here I'll work through an example, and then I'll give you one to practice. So we have 5 data points with the following properties. Our mean, our median, our range are all 7. The mode is 10. What are our 5 data points? When trying to go in reverse, you should do this same process to start all of it. We have 5 data points. Let's call these 5 data points A, B, C, D, and E. These are our 5 data points. Additionally, these data points, let's make things easier on us, put them in order. So we are going to say that A is less than or equal to B, which is less than or equal to C, less than or equal to D, less than or equal to E. So now that we've done that, let's work with what we have. Let me double check there's nothing in the chat. Let me pull that up. Okay. So our median is 7. We have 5 data points. That's an odd number of data points. So of our 5 in order, first, second, third, fourth, fifth, which one is going to be 7? First, second, third, fourth, fifth. Our third data point is going to be our median, which is 7. Well, we put these in order. So A, B, C, D, or E, which one's the median? A, B, C, D, and E. C is our median. So we know this is 7. Let's go to our next one, our mode. Now, the thing is, you can do this in whatever order you want. I'm just doing the one where it's easiest to get your answers. Our mode is 10. We recall from the definition of the mode, in order to have a mode, we have to have at least two of them. 10 is higher than 7, so our mode has to be to the right of C. But there's only a D and an E. That's it. There's nothing else. Since we have to have at least two data points to have a mode, D and E both have to be 10. Before I continue, so let me put the arrows. 10, 10. What I have done so far, does that make sense? I don't know why it keeps hiding the chat. Yes, so I recommend when going backwards, try to always do the median first. The median is almost always the easiest one. The only time the median can give you troubles is if you have an even amount of data. If you have an odd amount of data, the median gives you the first one immediately. Usually you can get the mode right after that. So now we have A and B. So now let's go to our range. We recall our range is equal to our highest minus our lowest. We have these in order. So our highest is E, and our lowest is A. Well, we just got E. E is 10. We don't know A yet, but our range is 7. So therefore, A is 3. That makes sense? So now we know A is 3. Finally, we will work with our mean. Our mean, we sum up all of our values and then divide by the total number of them. So here, that is going to be the sum of our values. So it's going to be, I don't know, we'll just call these xi's. And we divide it by our total number, which is 5. And we know this is our mean, which is 7. Here's what I recommend doing. Instead of writing it that way, the sum of our values is equal to our mean times the sample size. So this is something I'd actually recommend writing down. An alternative way of writing it is that the sum of our xi, I already wrote it down earlier, but I'll write it again, is equal to x bar times n. When going in reverse, it's better to do it that way. Well, guess what? Our mean is 7, and our sample size is 5. So x bar times n is 7 times 5 is 35. So we have the sum of our xi is 35. So that means, move this out of the way a little bit, we have A plus B, because these are our data values, A, B, C, D, E. A plus B plus C plus D plus E. Those are our data values, and the sum of those has to be 35. Well, guess what? E is 10, D is 10, C is 7, A is 3. All that leaves is to find B. So we start with 35, subtract our E, which is 10. That's 25. Subtract our D, which is also 10. That's 15. Subtract our C, which is 7. Now we're down to 8. Subtract our A, which is 3, 5. So we're left with B is equal to 5 by plugging all of this in. And sure enough, we want to double check. Our mode is obviously 10. The median's obviously 7. Our range, 10 minus 3, that's 7. That checks out. And if we add that up, 3 plus 5 is 8, plus 7, that's 15, plus 10, 25, plus 10, 35. Divide that by 5, 7, all checks out. The nice thing about these logic problems is you can always check yourself. Yes. So we know our mean is 7. We recall the sum of all of our data values divided by however many of them there are is our mean, right? So therefore, we can multiply by n to see that the sum of our data values must be our mean times the number of them. That makes sense? So our 35 came from multiplying 5 by 7. Now, I'll do a couple more ones because this one was very straightforward. Some of them, you actually have to start using some logic. On the assessment, I'll keep it more so towards the easier end, but I want to show you some of the harder ones anyways. Just 2 more and then we're done. Here's the next one. 5 data points with these properties. The mean is 5, median is 6, the mode is 3. All of them are integers. What are the 5? We have an issue. We don't know the range this time. We're only given 3 of them. Yes. Oh, did you have a question? Okay. So here, Again, we have 5 data points. We start as before. We have our 5 data points. We'll call them A, B, C, D, E. I'm sorry, no F. A is less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E. The whiteboard is always going to be on Blackboard. Always. I always put that on Blackboard. Now, as a note, I believe on the assessment, it will be 5 data points. So you'll pretty much always start out this way. So instead of me starting it, I'll ask you a quick question. Mean, median, mode. Which one should we start out with? You can just yell it out. Median, yes. We have 5 data points, midpoint, because guess what? Technically, even though we don't know what they are, we already put them in order. We're basically cheating a little bit. We're not cheating, but it feels like cheating. So our median is 6. That's C, because it's our median. And pretty much when you do the assessment, you're pretty much always going to start out the same way, start with the median. Now, let's go to our mode. Our mode is 3. We recall with our mode, there has to be at least 2 of them. So how many 3s do we have? 2. Are they going to be A and B or D and E? A and B, yes, because the A and B have to be less than C. So because of our mode, we know that A and B both have to be 3. Now here's the thing, if we had the range, we could get E pretty quickly. We don't have the range, so we can't. So let's go with our last one, our mean. Now again, notice it says all are integers. We're going to use that in a moment. All are integers. So we recall the sum of our data points is the average or the mean times our number of data points. So we add up A, B, C, D, and E. And this is going to be equal to our average, which is 5, times our number of data points, which is 5. Before I continue, does that make sense? Okay. Oh, what is this thing doing? So, let's keep going. Can I do that right? Oh, no, it is right. Oh, that's cheeky. That's cheeky, but it's right. Oh, that's sneaky. All right, I'll keep going. That's really sneaky. I made it myself, but I notice now it's a little bit sneaky. Anyways, our A is 3. Our B is 3. Our C is 6. We don't know D. We don't know E. 5 times 5, 25. 3 plus 3 is 6, plus 6 is 12. So we have 12 plus D plus E is equal to 25. Subtract 12 from both sides. We have D plus E is equal to 13. You might say, what now? We have no more information. Yes, we do. All of our data are integers. So to get 13, we can have 1 and 12. We can have 2 and 11. We can have 3 and 10. We can have 4 and 9. We can have 5 and 8. Or we can have 6 and 7. For all of those, except for 6 and 7, let's say we took 1 and 12. Well, obviously D would be 1, but then we'd be saying 1 is greater than or equal to 3. That is wrong, so we can't do that. Likewise, let's take 2 and 11. Obviously D would be 2, but then we'd be saying 2 is greater than or equal to 3. Can't do that. That one's out. Now let's say we took 3 and 10. You might say, oh, 3 is greater than or equal to 3. We're good to go. No, we're not, because 3 is not greater than or equal to 6. The same logic keeps holding until we're down to 6 and 7. Our only two, and we can't go decimal because it says there's no decimals. So by logic, we have D and E are 6 and 7. There's a question you might ask yourself. Okay, this satisfies everything. But we have 2 6s. That means we have 2 modes. We have 3 and 6. That's correct. It didn't have to give you both of them. So in this case, we do this with logic. And what I'll do here, I won't do it now, but I'll type it out after class because I don't want to waste too much of your time. after class, I'll type out how I got the 6 and 7. I mean, I just told y'all now, but for those who went home or whatever, I will type that out for them. Again, no. I mean, if it said the mode was 3 and 6, you're done. You didn't even need the mean. So it's not going to be that easy. But again, no, this is bimodal. It just didn't tell you that. So we continue. Does that make sense? I'll give you a 5 times 5. So we recall up here, Colin, we have the sum of all of our data points is equal to our average, x bar, times our sample size, n. This is rearranging the formula for the mean. When you're doing these logic problems, use that definition of it. Like you'll see with a lot of these formulas, we can rearrange them. Sometimes putting them in one format makes it much easier than using the other. So that's where the 5 times 5 comes from. Now what I'll do, here's a last one. I'll give you 2 to 3 minutes to work on it to give you a try. We should be done in no more than 6 minutes. Sorry for keeping you a bit late. I didn't want y'all to have material we didn't get to for the exams, but mostly because we spent a lot more time than I thought we would on the graph stuff. So here's one here. Guess we give this one a try. You should find this one to be the easiest of the 3. So I'll give you until 36, and then we'll go through it. Those of you that actually work through the Sudoku puzzle on the bonus exam should now be very clear why I recommended doing so, because there's logic stuff here. An extra minute, hopefully that should be enough. For those of you that have seen the trick to this one, you'll see it's the easiest one we've done. All right, does anyone need any extra time? Does anyone at home need any extra time? All right, let's go through it. What's the first step? I don't want to yell it out. No, okay. First step is always list out your values, put them in order. You don't know what they are, just put them in order. We have 5, A, B, C, D, E. We put them in order. Now, there's no median. We can't start with that. We do have modes at 4 and 7. Now, here's a question you might ask yourself. We could let A and B both be 4, or we could let B and C be 4. Likewise, with our 7, we could let C and D be 7, or we could let D and E be 7. How do we know which one to do? Nice one is, doesn't matter. You'll see why in a moment. So for now, here's what we know. We know that 4, 4, 7, and 7 are 4 of our data points. This makes sense so far. All right, and we have one more data value. It could be C, D, or E. We know it has to be one of those 3, because if it was less than 4, then the mean couldn't be 6. So that's an indicator it's going to be one of those. We'll just put a question mark. That's our last one. We know the mean of all of these has to be 6. So using our thing from before, this formula, like I said, you see this quite a bit. The sum of all of these, so 4 plus 4 plus 7 plus 7 plus whatever the 5th one is, has to be equal to our mean, which is 6, times our number of data points, which is 5. Okay? 4 plus 4 is 8. 7 plus 7 is 14. So we have 8 plus 14 plus something. 6 times 5 is 30. So we have 22 plus something is equal to 30. Therefore, our something is 8. So this is 8.
8.
Yes, that is correct. So we know it's going to be 8. This is 8. Hey, it's already in order. How nice. Totally not a coincidence or anything. So you can say A is 4, B is 4, C is 7, D is 7, and E is 8. Now, if I wanted to, here's what I could have done. Instead of saying, what are the 5 data points, I instead could have said, what's the median? You couldn't find the median without getting all the values first. On the exam, something I might do is give you 3 of them and say, what's the 4th? As a practical matter, this one right here that you did for practice, that'll be a little bit easier than one on the exam. However, of the 2 practice problems I did for you, this one right here should be harder than the one on the exam. The one you saw right here, this first one, that will be the one that's going to be closest, both in terms of difficulty and what you'll see on the exam. The only difference, instead of just a bunch of random numbers, it might give you, say, prices. Like, might give you the prices of 5 things, but instead of those 5 things, give you data about them. So that's all we have. I will do variance and standard deviation in the next one. I apologize for going a bit over. We just spent a lot of time on the graphs. What I will do is, for this one right here, I'll type out the logic that we used to get it with 6 and 7. I will post this to Blackboard as well. So that way, those of you that didn't write down everything or those that had to leave earlier, you'll be able to look at that there as reference. Other than that, y'all enjoy the rest of your nights.